Time for some more linear equations. We are checking out section 5.2. So we are looking at linear equations that are specifically in this form. Will let my pen work? There we go. So we're looking at y equals mx. And even better, if you can think of this form as y equals mx plus b. For right now, this term we're going to be adding is going to be a 0. So it's truly y equals mx plus b form, but we don't always put the plus b because sometimes it's a 0, and adding 0 is repetitive to say. So our learning goal for today is that we can write and use linear equations. And we'll be looking at some real-world problems for how these are useful. So part 1 shows the graph of the distance of a car, which is represented by the letter D, that it travels in time t at a constant speed r. So let's look at the graph. We see our title up here, distance traveled by a car. Along my x-axis, I'm counting the time in hours, and my scale is counting by ones. My y-axis is my distance measured in miles. And here my scale is counting by 30. So this line then is going to show the relationship between the distance I travel and how much time it takes me to travel that distance. So this line itself is showing that constant speed or rate, r. So first for part A, what is the constant speed of the car? Well, as I look at this line, as we mentioned, we know it's straight and it starts at 0, 0. So this represents a proportional relationship, but it's also a linear function. So as I look at this, I know that the speed is constant because the line is straight, so I can simply look at my unit rate on the graph. In 1 hour, what is the distance that I have gone? So my speed or my rate is going to be my y to x ratio. So I can go 30 miles per 1 hour. So my constant speed is 30 miles per hour. If I want to know how far the car will travel in 2 hours, then I look for 2 on my x-axis and I find the point on my line where x equals 2, and I can see that in 2 hours the car has traveled 60 miles. And for part C, how long will it take the car to travel 120 miles? I'm going to find the point on my graph where y equals 120, and that would be at 4 hours. And finally, if I want to write an equation in d equals r times t form, distance equals rate times time, that's going to model this situation, then I'm going to use this constant speed that I found. That's going to be my slope. That's telling you how steep my line is. So from one point to the next, I'm basically rising 30, running 1. Rising 30, running 1. Rising 30, running 1. Rising 30, running 1. So that's my slope or my rate. So I substitute that in for r in my equation, and I have the equation d equals 30t. So now my inputs would be my time, my x values, and when I put a value in for time, I'm going to get out the distance that goes with it. All right, let's check out this example over here. This graph shows the distance d of a train that a train travels in time t at a constant speed r. We want to write an equation in d equals rt form, where distance equals rate times time, that models this situation. So just like we did in this first example, I'm going to find that constant speed. So I'm looking on my graph here, on my line, for a point that I can name the exact location of. This point right here, it's crossing 50 on the y-axis, but I would have to guess what x value this is. So I'm going to keep going to this point right here because it's in the corner and I know the exact location. After 1 hour, we've traveled 150 miles. So this is my unit rate. This is my slope. Every 1 hour, I'm going to travel another 100 miles. So I go up 100, run 1, rise 100, run 1. So if my rate is 100 miles per 1 hour, then 100 is what I substitute into my equation for R. So I would say D equals 100T. And that's my rule for the equation. So let's check out our key concept. Remember that the graph of a proportional relationship is a line and that it has to pass through the origin, which is 0, 0. An equation that models a proportional relationship can be written in the form y equals mx. And this equation shows y is always a constant multiple of x, and m is that constant multiple. So I'm always multiplying x by m in this form. So an equation in the form y equals mx is always going to be an example of a linear equation. So remember, when we have a linear equation, we know it's linear if the graph of all of its solutions makes a line. So let's go ahead and check out part 2. A restaurant is running a lunch special. Write the equation that models the lunch price y based on the original price x. It looks like it's jumbled some of this up. Sorry, disregard this. I'm not sure why it has that there, but we're going to ignore it. Okay, so I know that all prices are 1/3 off. So I need an equation that models the lunch price y based on the original price x. So if my lunch price is 1/3 off, I know that I can take 1/3 and multiply it by the original price, and that's going to give me my lunch price. So 1/3 of x. Of always means times, and this fits my y equals mx form perfectly. Let me grab this other question for you that got a bit jumbled here, and let's work so you can get that extra practice too.